Hello friends, now we are going to discuss about the dissolved oxygen. Dissolved oxygen, it is the amount of molecular oxygen dissolved in the water. When water is exposed to the atmosphere, many gases are present in atmosphere are going to dissolve in water. In that, oxygen also is going to dissolve in water, and because of this dissolved oxygen only aqueous life is exist. And this dissolved oxygen can be determined by Winkler's method. Here, in the Winkler's method, the dissolved oxygen is determined in terms of iodine. How much amount of dissolved oxygen is there, that much amount of iodine is produced. And that iodine is going to react with standard sodium thiosulfate solution by using starch as an indicator. The principle involved in the Winkler's method is the dissolved oxygen whatever present in the water, it is not going to oxidize the potassium iodine into the iodine. Potassium iodide into the iodine. Therefore, this requires an oxygen carrier like manganese hydroxide, which is produced by the action of KOH and MnSO4. When manganese sulfate is going to react with KOH, and it is going to produce the manganese hydroxide and potassium sulfate. Once the manganese hydroxide produced in the water, this manganese hydroxide is going to utilize the dissolved oxygen present in the water, and it is going to produce the brown precipitation of manganic oxide. Once the brown precipitation is formed, this brown precipitation of manganic oxide is treated with concentrated H2SO4. When it is reacted with the concentrated H2SO4, this manganic oxide is going to convert into manganese sulfate and water, and it is going to produce the nascent oxygen. Once the nascent oxygen is produced, this nascent oxygen is going to oxidize the potassium iodide into the iodine. How much amount of dissolved oxygen will be there, that much equivalent amount of iodine is generated. And to this iodine containing solution, we are going to add the starch indicator. This iodine will form the weak complex with the starch indicator, that is blue colored complex is formed. And this blue colored solution is titrated against the standard sodium thiosulfate till the disappearance of blue color. In this reaction, sodium thiosulfate is going to react with iodine, and it is going to convert it into sodium tetrathionate and sodium iodide. How much amount of dissolved oxygen will be there, that much amount of iodine will be liberated, and this iodine is determined by using the sodium thiosulfate solution and by using the starch indicator, and the calculation will be done. Here, many more impurities present in the water, they can interfere in the determination of dissolved oxygen by converting potassium iodide into iodine. So, here nitride or sulfides like impurities, they can convert the potassium iodide into iodine, but we need the only conversion of oxygen potassium iodide into the iodine. That means we need the oxygen oxidation of potassium iodide into the iodine. So this impurities interference is avoided by adding sodium azide. The procedure involved in the Winkler's method is, here we are going to take the 250 cm cube of water sample taken in the Winkler's flask. Then we are going to add the 2 cm cube of MnSO4, that is manganese sulfate solution, and alkaline Ki. Alkaline Ki means potassium iodide is dissolved in KOH solution, along with which is containing sodium azide of 2 cm cube solution. Then this Winkler's flask stopper is closed and it is shaken well, so that brown precipitation will take place. During this reaction, this manganese sulfate is going to react with KOH and it is going to form the manganese hydroxide. Once the manganese hydroxide is formed, that manganese hydroxide is going to react with dissolved oxygen and it is going to form the magnetic oxide, and that brown precipitation is formed. Then we are going to allow that brown precipitation to settle down. To that brown precipitation, we are going to add the 1 cm cube of concentrated H2SO4 in order to dissolve the precipitation. This brown precipitation will dissolve in H2SO4 because H2SO4 is going to react with magnetic oxide and it is going to produce the manganese sulfate, water and nascent oxygen. And whatever the nascent oxygen is released, that nascent oxygen is going to react with potassium iodide and that will be converted into iodine. And iodine is released here. We are going to pipette out the 100 cm cube of solution into the conical flask and it is titrated against sodium thiosulfate solution till it turns into pale yellow. Then when it will turns into pale yellow, then we are going to add the 2 to 3 drops of starch indicator. Then it is titrated against the sodium thiosulfate solution till the disappearance of blue color. Here at the first point only we are going to not add the starch indicator at the first, because at the higher concentration of iodine present at the first point, so that at the higher concentration of iodine, starch will form the highly stable complex with iodine. Further reaction will not take place. So that we are going to titrate the sodium thiosulfate with iodine. Then the concentration of iodine is reduced in the conical flask. Then it is become pale yellow. That pale yellow solution, to that pale yellow solution we are going to add indicator so that it will become blue color. Then again we are going to start the titration with the sodium thiosulfate solution till disappearance of blue color. The calculation involved in the titration is volume of water sample taken for the titration, that is V1 ml. That means how much amount of water we are taken for the titration, that is 100 cc we are taken in this example. Normality of water sample, it is 100 ml is there, make it correction N1. It has to make correction, it is a N1. Volume of thiosulfate used for the titration is V2 ml, that is burette reading, and the normality of thiosulfate used for the titration is equal to N2. Therefore, we know that N1 V1 equal to N2 V2. Here N1 V1 are, N1 is the normality of water, V1 is the volume of water taken in the titration, N2 is the normality of sodium thiosulfate, V2 is the volume of thiosulfate utilized in the titration. Therefore, we need the normality of water here. Therefore, normality of water is equal to N1 is equal to N2 into V2 divided by V1. Therefore, N2 V2 is divided by 100 because V1 is equal to 100. Therefore, the total amount of dissolved oxygen is equal to normality of water into equivalent weight of oxygen. Therefore, normality of water is equal to N2 V2 divided by 100. This into equivalent weight of oxygen, that is 8. Therefore, this dissolved oxygen can also express it in the ppm. This can be done by N2 V2 into 8 into 10 raised to 6 divided by 100 into 1000. Whatever the answer will come, so that will be expressed in ppm.